Number 8, what's the domain and range of the quadratic function? So my domain is all real numbers. I can square any number. My range has to do with that 4. Since I have a negative, my parabola is facing down. So I have a max. So y is less than or equal to 4. On number 9, I have 1, 2, 3 transformations. That negative is a reflection. Across the x-axis. When I add 2 on the inside, that's making my function go to the left. And then when I subtract 7 from my y values, going down 7. Now I'm going to graph the parent function and our transform function so we can see what they look like. So that's a parent function, y equals x squared. And that's our transform function. So it's upside down, so it's a reflection. And the vertex is left 2, and it went down 7. If it didn't have that reflection, if it was still facing up, let's see what it would look like. It still would have went left 2, down 7. Number 10, if a system of 2 linear equations has infinitely many solutions, the graph would show which of the following: 2 identical lines, 2 parallel lines, at least 1 vertical line, and 2 intersecting lines. To have a solution, you definitely need 2 intersecting lines. So that's a maybe. At least 1 vertical line, that's not necessarily something we look for. 2 parallel lines, that would be no solution. So that's out. So 2 identical lines. So intersecting, that's not specific. That's saying that I have a line, that I have a line that crosses. So that's only 1 solution. But I'm looking for infinitely many. So what would A look like? If I had a line, and I drew another line right on top of the line, right on top of it, it would cross itself at every single point along the way. So every single point along here is a solution. That's infinitely many. So it has to be A. So 11, it says the BHS Theater collected $1,415 for 375 tickets sold at their school play. If adult tickets were $5 each and students were $3 each, how many of each were sold? First thing that pops in my mind is Matrix. You could make equations and solve by elimination and all that, but it's just easier to make a matrix. Okay, so you were told two things. You were told about money and you were told about tickets. For money, you knew the cost of adults are $5, cost of students are $3, and they collected a total of $14.15. Adults, that was one ticket was $5. Students, one ticket was $3, and 375 tickets gave them $14.15. So this is our matrix. We have a 2 by 3. It's a 2 by 3 matrix. Okay, so there's a shortcut for matrices that I just figured out maybe a week ago. You can do everything in the home screen using the alpha button. And there's little function keys. First, we need to go to the matrix window though. Second matrix, and get our math operation. We want B, our REF. So from there, I'm going to press alpha, zoom. I need to arrow up. I want a 2 by 3. So arrow down to OK, press enter, and it pops up right there. So now I'm going to put my values in. 5, enter. Oh, I can't press enter. 5, 1, 1, 3, 7, 5, 3, 14, 15. So I just have to keep arrowing across. Little direction arrows. Just arrow through and find the entry spot and then just type in the number. Then I press enter and it gives me my answer. It's 145 adults, 230 students. Number 12, systems of equations. But it just says right. So I'm going to make my matrix, and then from there, I'm going to write the equations. And I have jeans, shirts, and hats. So I'm going to have my money relationship. I have number of items. And then I have 3 times the number of shirts as hats. $25 a pair for jeans, $15 for shirts, and $10 for hats. So it says to say X is jeans, Y is shirts, and Z is hats. And the total was $215. So that's my first equation. She bought 14 items. So somehow X plus Y plus Z equals 14. And then she bought 3 times the number of shirts as she did hats. So she has more hats, or she has more shirts than hats, which would make sense. So she has no jeans. So shirts plus 3 hats equals 0. This equation should have been shirts equals 3 hats. And so either way, if I moved one over, one of them has to be negative, and it's going to equal 0. All this matrix stuff is Unit 3. And now we have 13, square root. This is Unit 5. So I need to isolate my square root. So I'm going to subtract 4. So from there, I'm going to square both sides. And when I square the square root, I get what's inside the square root, 3x minus 8. When I square this, I'll put it over here. X times x is x squared. X times negative 4 is negative 4x. Negative 4 times x is negative 4x. And negative 4 times negative 4 is positive 16. So negative 4x and negative 4x add to be negative 8x. So x minus 4 squared is x squared minus 8x plus 16. So I'm going to subtract 3x and add 8. I want the side that does not have my square to be 0. So I have x squared minus 11x plus 24. So I need 2 numbers that multiply to give me 24. It's me like 8 and 3. X and x. They both have to be negative. Negative times a negative is a positive. A negative plus a negative is a negative. It's equal to 0. If x minus 8 is equal to 0, and x minus 3 equals 0, then here, x had to have been 8. 8 minus 8 gives me 0. And here, x had to have been 3. 3 minus 3 is 0. So I need to go back to my original to find out if one or both or neither actually works out. So I'm going to do the square root 3 times 8 minus 8 plus 4. Does that give me 8? Yes. What about 3? That does not give me 8. So my only answer is 8. X equals 3 is extraneous.